Okay. Oh, this side says error has been. Something or the other is always a problem.
Technology is not our friend, is it?
It's okay, the lights in here probably won't keep dimming and coming
You
back.
know what?
Wondering about it.
That's fine. I don't need to. Okay. So we just once again just call me Sundar or T. So it doesn't matter, whatever is convenient to you. So the first thing which we want to talk about is I will give you some sheets based on which I'll put up some questions. You will possibly as teams answer some questions and we will share them with each other what they mean quickly. So I've picked phase change as one of the exemplar lessons because I wanted to talk about something which is connects to multiple things. Earth science, chemistry, physics, anywhere you go. There is something which is related to that. So I said like, no, physical science, this may be an easier one to work with and viable for a lot of things. So let's do the first thing. I'll keep toggling between two documents. Okay. Again, they could not print stuff for me. So we're going to first address the two questions. What is phase change? What are they? How do we recognize phase change? So I'm going to give you some sheets of paper to work with, and possibly we will use the same paper if we did not finish it, more and more of it to start with.
We would know what the physical faces are. That's phase change. It'd be like, well, they can't do it in elementary school. They can do it in
Take a marker and pass it on, please. Take a marker and pass it on, please.
we do it because we do it in 8th grade.
2 years
Because I
ago,
just taught
it
it.
was a buy one, get one free. Thank you. So I was like, okay, sorry. Done. But I got the graphic.
See, the graphic for one, I feel like it's really.
And so I can make it.
Like, but if I ask my 7th graders, what are the phases of matter? They can tell me using that terminology. Like if I say, what are the phases of matter? They can tell me what they are. But if you just pick up there and say, what is a phase? What is a phase change? They'll go. Like some people say, what's the change of state? They mean just like okay, so I don't have to get on science for a year or so. And like, what's the vocabulary or the terminology?
So let's keep answering the questions as we start off. Who's got a paper can start off right away. Since we are running into
Phases from
yes. I'll get you a marker.
gas, is that what they're actually?
Do you have some markers, please?
Plastic.
Sure. Here, pick a marker. So we are addressing the two questions.
I guess we can.
You may be wondering why I asked this question of what is phase change. Many of you know at higher level in grad school or something like that, you have seen other things which are also called phase change than what we normally talk to children about. And one of the things I always try to keep focus on is keep focus on the name. If children come up with weird meanings for that other than what we know, it may be useful sometimes. So it may be something which they will come across somewhere else, and people do use those words in other places. So it is okay to connect to the word. So you can say what is phase change, what are they, and how do we recognize phase changes. And that's what we want to talk about. Also keep in mind that what would we address to the teacher, children? Like what would you think about addressing to children at your grade level? So because different people will be working at different grade levels and different content area. So please address the first two questions. How do you address them?
So I guess
just right.
Physical
change.
Well,
Phase change is the process of changing from one state to another. Right.
Question, one question.
That's not a very good way to say it. You mean like Hawaii? Like Virginia?
I was just looking at standards for sixth grade because I have to teach
I can-
astronomy next. I was thinking about phase change from the moon. Right, so it could be that too. So what are we talking about here?
Phases.
So
And then what are they? Solid, liquid, gas, plasma.
Sure.
like the rest.
You have nice handwriting, so.
Yes, you do, much nicer.
Just solid, liquid, gas, plasma.
No, phases of the moon, but it's a
Say
phase
solid,
change
comma.
going from one phase to another.
Energy
Well, that's
levels
where
of
it like
molecules.
going from one state to another, right? But not really defining what state you're talking about.
Going from one state to another.
Just signals.
No, we get to how do we recognize appearance?
I mean,
So it would be observation.
Oh, what signals?
Characteristics.
Yeah.
Characteristics.
But like, as long as like how to,
Appearance.
I almost think like that
more
would be.
than just like the molecular, because
What do we see? Like, where do I know such things happening?
He's like, what are you guys teaching? You guys are not. So we want to see it. So you want us to say melting or evaporating.
Or even not that. It becomes, even if I say that is now falling apart, whatever it is, what would you say to the children? Because children don't have the, quite often do not have the imagination to think they have. Like, you know,
So they're like biology.
well, see, because my problem is
What are the phases? Solid, liquid, gas.
There's a change.
and then they don't understand, they can't make a transition from water to like anything. So they change from one state to another, by everything by way of changing energy. Yep. That's obviously different data. Or energy transfer.
Melting slash freezing.
Yes, the graphs look similar, but they're not exactly the same.
Has anybody told you that's like going from Alabama to Mississippi?
So
Not yet, no. But we just talked about how we talk about like
favorite
new phases from stage.
You'll always find one weird.
What is it called?
But she was talking about the moon phases.
these are all
Or mitotic phases.
And the thing is, if the child comes from a social studies class, and you have to right away talk about this, it's like,
I know, that's what we're saying. Yeah.
Okay,
So,
so
but
do we want to use water or do we want to use?
or just do chemical phases, moon phases.
We talked about the whole numbers. Why is it not a whole number?
So we might have to use,
I'm thinking that this is a little bit more global to science. I mean, I heard
once
that
we get into this.
you're talking about the phase changes.
Of
this. So I don't want to go so far down the rabbit hole of one narrow focus because we are
Phase changes.
trying to
Open it up. So anything phase change.
That's kind of where I was, you know, talking about the phase of signal. You
Well,
said
but
that.
don't be the lab
How do we recognize
where
these
they
phases?
actually separate
How do
out.
we change it? Those
One
do those
thing
words.
Melting,
Melting, freezing.
looks different ways or acts different ways.
You could just put
And the sand remains.
So the thing itself didn't change, but our perspective or our way that we interact with it has changed.
No, I would just do solid, the one, the gap. Are we working on question 3 yet? To keep it simple.
no, not yet. I just want to share, you will realize that how much amount of variation we do have even the first 1 or 2
I know.
courses.
Now the moon phases.
We'll come to the third question in a minute. If you want to work on it, that's okay. Change in font. Look, in a minute we will come back to,
Yeah, we're going. My topic.
that's really low temperatures.
so what did you see as
Gas, plasma. Thought there was
more than one phase is
Yeah?
present?
state of
That's what you see.
Phases of
MITOTAC. I know.
super, super
I can't
cold.
spell
Growth
I cannot
stages.
spell verbally.
Starts with the guys who found it.
Really?
What is that?
Cells. You know,
Einstein.
interphase, prophase, metaphase.
Okay.
Einstein. Who else? Bose-Einstein.
Okay.
Cell cycle. Cell cycle.
Yeah, there's a fifth state of matter.
Typically, it's easier on you.
You're trying to be very creative.
we still
Appreciate your creativity,
I
but
think we're kind of open. In general, all right, because I was gonna say, in some cases, these phases, you can go back and forth. In some of them, they are unidirectional.
Correct.
They are.
So, okay, so this is these right here, unidirectional.
Actually, rock cycle is not.
No, you're right. But this one.
But yeah, metamorphic.
These
But
are
is that a phase change?
Cyclical,
but it's not really.
but it's not. But it's not. You can't go backwards. It is unidirectional.
Yeah, you're right. It
because
doesn't go this way.
Right.
But it's still a
Right.
It's a super
Yep.
So this one would be like freezing,
So-
melting.
So really, that might be one of. I mean, when you talk about rock cycles, when you talk about phase changes.
Thank you. So, can you please display your papers here? One of you can be a spokesperson for your team, and you can work it out. So when I give you the control, you can just press the. You can take that thing with you. There's my. Okay. I will place it for you.
It won't go right here next like this is.
When I used to teach this in physics,
Yeah.
But it reminds me of the leaf.
So when I give the control, all that you got to do is press the center button, facing that line. It's just like a remote. Basically, it's like a remote. Face it and press the center button. It automatically turns to you rather than me. It's yours.
I'm taking it away. Okay. So I push the center button, and now this is great. This is awesome. I'm loving this. All right. So we didn't quite get to questions 3 and 4. When we said what is a phase change, we started out with like restructuring of molecules, the different energy levels of molecules, and we identified solid, liquid, and plasma. Gas and plasma as different types of phase change. And then we thought, well, isn't there other places that we've heard the word phase change before? So we said, for example, like the different phases of the moon could be considered a type of phase change. Metamorphic phases, like if you're thinking of biologically a caterpillar moving through different phases of becoming a butterfly. Rock cycles, how rocks go through different phases. I said, well, these different phases, they seem to sometimes have different directions associated with them. Sometimes that's bidirectional, like with solids and liquids, things can move in between. Some of these other phases that we kind of thought through seem to be one directional, or some of them are cyclical, others are not cyclical. So direction kind of played a role. Then within the category of physical phase changes, we said, how do we recognize it? We said, well, we have melting, freezing, vaporization, condensation, sublimation, deposition, and then in general, as a kind of a working definition that describes it all, changes of an object over time or changes in an organism. When the thing that is, it's the same thing, but the way it looks, we perceive it differently. So,
thank you. Great. So the next team.
We still have control, so it's facing this low.
I have released control. You can take control, sir.
Do I have to?
Yeah, you can. Yes.
Hey, I do. Well,
It doesn't seem to be following him yet.
Rudy. Okay.
No.
Should we
Yes.
turn off
Go.
ours?
Go.
It's a center thing, right?
Yeah. Center thing. Yeah.
Good?
Yeah, you're good.
Cool, I don't like watching myself. I will go against some of this, but I mean, phase changes there are what, like 14 or 15 different phases of matter. Sticking with solid, liquid, and gas, then your basic phase changes is the addition or removal of that range of motion. And that'll get into your intermolecular forces and your particular forces. And it just, that's how I perceive it. But anyway, you have your classic phase changes, your melting, freezing, deposition, sublimation. I love talking with the kids about vaporization because, evaporating and boiling, if they haven't thought about it yet, they should think about it, that they're not quite the exact same thing, but they don't really thought about it yet. Like how does water boil on a road when it's wintertime? But it doesn't, but it still changes the phase, And basically to find that whole, how do you perceive a phase change? Phase change is just whenever two phases are present at the same moment in time. The only way you perceive whether something's melting or freezing is basically the energy flow because you have context. But without that context of whether something's getting hotter or colder or something like that, then basically it's just when the two phases are present, and that gets you easily into the triple point and things of that nature because multiple phases are present at the same time, which means multiple phase changes are occurring at the same time.
Thank you. Okay.
Holy crap, there are like more than 15
Okay.
phase changes.
So you would be able to go now? Let's see.
We don't have very much time.
It's okay. You just add the ones that you want to say which are different. We can talk about them.
I think we still have control of it.
Go ahead.
Me?
So,
Here's your thing.
do I need that?
It's okay. I'll stay with you here.
Oh, okay.
Okay,
So, we put the process of changing from one state to another by way of energy transfer, solid, liquid, gas, plasma. And then I said that I remembered when I taught 5th grade, I talked about Bose-Einstein condensate. Just had some of the kids that went home and looked it up, Googled it, that type of stuff. And then, but then we talked about how you could recognize change, just simply appearance, temperature, and pressure, because of the level of students that we teach, that appearance is the biggest thing that they see from one phase change to another.
Okay.
And then we talk also about, well, then you have to talk about energy and energy transfer and how the law of conservation of energy, and just so I made it simple.
Thank you.
Oh,
Oh,
it's a touch screen.
It's a touch screen.
I'm sorry.
If you go back to where you wanted it to be,
Yeah.
touch screen.
Cool.
Yeah. I'll just pause it. And you can unpause it if you want to. You can move it.
Yeah, go ahead.
But I'm short, so I have to learn to jump.
All right, so basically we're saying the same thing that everyone else has said. A phase change is going from one state to another, and so we started talking about there's a chemical processes, the solid, liquid, to gas phase changes, moon phase changes, cell cycles. Most of the time when we recognize it, it's through an energy change, the movement or change of different molecules, the visual, the appearance. What is going on? Did I miss anything? All right.
Thank you. The next team go, please. You can put it on anywhere there. You can put it there.
Biology. You're just like glanced over that word, so I'm like, I'm not sure if I'm going to say it right. Well, it's mitosis. Yeah, right.
Okay.
But they're called mitotic. The
Go ahead.
phases are called
We
mitotic.
talk about the energy change. We talk about how is kinetic molecular energy of the molecule changes from one state to another, and how is the melting point and the freezing point could be the same, or they are the same, and you need to do the energy to go from freezing to melting, or melting to freezing, and what happens to the temperature during phase change. Why does it stay the same, and what affects that? And then we connect it to the natural, like the water cycle, the rock cycle, weather, and this is the graph we focus on 8th grade, depending on our SO, because this is what they see, and they always get the graph and label the graph, and why is it staying the same when we have the field change. So that's it.
Fantastic. So I'm just going to keep it here to make space for everybody. So the question is, how a simple word of phase change, which when I first thought about this, I never really realized. Every time I drive back and forth thinking about that name, just like you guys thought about it, so many things came in. Brian said, no, we need to talk about something with physics. I said, okay, something common, physical science, phase change. But then I realized it's going to explode into biology, into anything, into earth science, everywhere. And this is something what the children experience, and we need to dance with it. But still, we need to keep them focused on what we want to do. Like we're talking, change from one state to another. The guy walks in from a social studies class and say, from Pennsylvania to New Jersey. So, you get all kind of odd listening situations. It's fantastic though. So let's now ask the next question for us. Unpause this.
I did.
Yeah, okay. So the next question we want to ask is that we talked about the natural. Many of you have already talked about the natural and the other things. Where is my document? There it is. Okay. No, that's not the one which I wanted. Where are you? So we talked about a natural context and man-made context. You already made a lot of sense. Can we talk about natural? You already got into a lot. Can we talk about some man-made context? I'm just going to not really write all of these things, and what we're going to do is I'm going to just pass on the buck to one by one and see what you have to say about it. What man-made context can you think of in terms of this one? Sorry.
Traveling to the moon. You know, like that's,
Okay.
I just think of like the stages of, my son is obsessed with Kerbal Space Program, which is a video game where you build rockets. And so like I think of a space program has a lot of phases to it. There's the planning and the, you know.
Interesting. Other man-made contexts in which you're talking about in phases? It could not necessarily be what he's talking about, what she's talking about in projects. You could talk about in terms of normal solid liquid gases also in man-made context. That's fine with me.
Cooking.
Yeah.
Ah, interesting. Yeah. Cooking.
Oh, you got it.
Yeah. You got him hungry now.
No, I didn't get your question at all.
So, so man-made context of phase
You
change.
meant like anthropogenic uses of phase change or something?
Yeah. How are we utilizing? I'm looking like more towards how are we utilizing phase change in order to see, for instance, in nature, evaporation happens. That's okay. So we are on the same page?
So maybe you could have frozen drinks.
Well, we were thinking like maybe when we make plastics or.
Interesting.
3D printing, that use the phase change.
Fantastic. 3D printing, yeah.
It does.
Where they make it into liquid to solid, solid to liquid to liquid to solid back, and certain times it's under laser sintering. So many other things happen there. Fantastic.
Steel.
How about you?
Road treatment.
Road treatment.
Oh,
Yes.
yeah.
Keeping your body cool, like sweat, vaporizing.
That's the natural process. Also, we can artificially generate it also to a certain extent. Actually, I used to, yeah.
Our electronic signals, I think of like audio and sound, you know, constructive, destructive interference, and other phases of those match up.
Yeah. And interesting that when she went to do both condensation, I thought next you would talk about superconductivity. So I was waiting for that, my favorite topic. So
Using an Instapot.
because that's my research. Superconductivity. Okay, what is required for phase change to occur? Now let's slowly bring this together. And I want to talk about what possible things that are required for a phase change to occur in a physical process.
Pressure of energy.
Pressure,
Energy.
energy. Okay, temperature, yes. So, do we put in energy or do we remove energy?
It's a transfer of energy. It's
But what is energy? But how many of you, a lot of you in middle school, like I always have a struggle with what is energy? How do you describe to them what is energy?
like to our students.
Because I honestly tell you, when they come to Academy of Science, I tell them, they say energy. I said, I don't know that. Move on.
I always say the ability to cause change.
Yeah, I don't know.
The
Okay.
ability to cause change.
Yeah.
Okay. How about you, sir?
The ability to work.
Yeah. That's what I say.
See, he's being very technical. Like,
But you have to tell
yeah, you're right. No.
I don't have energy today because I don't feel like it.
Yeah.
Work is a hard one, because I feel like to define work, you use energy.
You're closer to my heart. I'm telling you.
That's kind of the idea, is I wanted to make that connection, so I was talking about.
I'm not fighting for you. You're closer to my heart. Like, I am the guy who says, I don't know what is energy.
But in the acceptance.
Until the words chapter comes, I never talk about it.
Well, what is it?
Good,
Changing
okay.
the energy of the
So,
system. So it's kind of like two sides of the coin.
so what do you say, tell children about what causes phase change?
I just say a transfer of energy.
Okay.
Can be input, can be output.
Okay, but there are going to be these questions which are existing when they come to classes like his or mine. We'll keep asking, like, what is this? And that question has to be, do you pose that? Do you really understand what I'm saying? What is energy? And does the question remain with them? Yeah.
I think that's where examples or models or things, like we model the water cycle to show the energy change. So we use a lamp to heat the water, we use dry ice, and another part of the model to cool it down, so they can physically see and you can feel the temperature change to kind of get where the energy is coming from.
But they also talk about the contradiction. The temperature changes and the phase does not change.
I think you need to talk about the motion of the molecules, because what you can do, I mean, you can go from like really just some Fermion theory of like no motion whatsoever. And then if you increase those motions, then you can actually talk about why. During the heating, it's easier for the kids, I think, to visualize that as they're vibrating faster and faster and faster, eventually they got to flip. And to flip, though, you have to break the connections. And just saying the energy is just how fast those things are moving, that allows them to actually get a better visual of what's occurring at its part.
Help us now identify the two forms of energy that is responsible for one that happening during phase change and one that is happening when there is no phase change. Help us with this. Yeah, so this is where phase change, bringing in the contradiction opens up the door for the two types of energy. How it is also present inside the material, not necessarily only when you drop an object.
Yeah, exactly. Two different definitions of potential energy. When they come into a chem room, they don't know the bond energies nearly as well as they should. But I mean, that's all new. But the whole idea of going up on top, what you just said, dropping something, you have the MGH for potential energy and stored energy for the bond. But if you talked about electrons and electron energy levels and bond formation being exo or endothermic and all that jazz, then you have a fallback into that. So I think phase change is far more complicated than make it out to be.
Okay. So, but it also yields to the lowest level child in second grade to first grade. It goes all the way to in college. You go to do research and phase change. When I was all my life, I was at that point of time I was working in superconductivity. It was all about phase change, but it was something else totally. So it is a very interesting kind of thing, and we should keep this thing alive in them. So now, at this point, I want to bring in a challenge you want to do. Students are given a challenge of moving a candle in a mold into a glass container without destroying the shape of the candle. But now I have pulled the phase change together into a small this thing. Now this is where the concept of what we talk about, why am I talking about this, is something which we need to look at.
I need to see the picture.
Is it liquid? Is it still okay?
Well, I'm thinking, is he talking like tea lights? Like the tea light into. Just run hot water. The tea lights inside the mold.
Absolutely.
Yeah. Then it goes into like a bubble where you can't fit the mold, because you could just pick it up and put it in. I think you want you to melt
Our
the
hot
candle.
water heater has the water turned like all the way up. I'm thinking of all my leftover candles, but I found out we always used to say that hot water was like at 7 level. Like it was so hot. We just turned it down. We just turned it down.
Light it, so it
Okay.
all melts into it.
This is where I'm going to this one.
Wick, right, to transfer the candles.
This is where our 2019 standards come in. The 2019 standards talk about in terms of engineering design. How to make children think about in terms of engineering design, or design-based thinking, or how to make things, how to unmake things. These are the central focus. So why do we want to make or unmake things? How is this going to be useful for children to learn? Can
Teaches them
anybody?
how to solve problems.
Pardon me?
Teaches them how to solve problems.
Teach them how to solve problems. And what else?
Critical parts for something out of the box.
Next one.
To use the parts to do something else.
Okay. And it also gives them some amount of hands-on work to think about and anchor their imagination to something which they can see and feel. So we want to talk about importance of phase change in engineering process, importance of phase change in natural processes, importance of phase change in separations of mixtures, importance of phase change in understanding energy in systems. So you see in how many different ways you can possibly talk about phase change in this particular way. So this is where your focus is going to be, and our focus is going to be, is that restructuring all our pedagogical processes by anchoring them to engineering design process. How you design, build, test, plan, improve, and communicate. But on the way, there are concepts which they are reflecting upon. Now, why are you doing this? Why not something else? And why should I pick this one and not that one? And they're very subtle things. And if you cannot just keep the candle on the top of can you keep a candle on the top of the hot plate and just pull it out? Why or why not? It melts.
Wax treatment.
Can anyone tell about what might happen?
It's going to puddle.
It'll melt, number one. Number two, what else happens with the hot plate can go to a temperature of something like about 200.
Burn. It's going to burn.
It's not you're going to flammable temperature, bang, it'll just go. You're going to box the ignition temperature at this particular point. So, but that means it may reach an ignition temperature even before water boils, kind of thing, and it's a problem. So this is where the engineering design component comes in. Like, what should I do? And second thing, engineering design. Why do I want to waste energy trying to overboil it when I only need this much amount of energy and not waste my money on energy? So these are going to be the define the problem, imagine, research, plan, build, test, improve, and share. So today we are going to do one activity to help us wrap our head around how we are going to reconstruct these curricular components. But still, all the curricular components must hit all the standards and all the requirements, but also wrap it around this possible framework. You're not saying that everything is going to be done along this home framework, but this understanding of it could be wrapped around this framework. And afterwards, you can do more practice and other things based on what is required for the testing process. So,
Rename the scientific process.
Very good. I was waiting for it. Somebody stop me. Somebody stop me.
The experimental design, it's the same thing. We just put engineering in front of it now.
What's the subtle difference between scientific method and engineering design?
So science is all about just understanding something. Engineering is all about solving a problem. So that's the big difference there.
But experimental design is that. You go back and it's problem solving, it's developing an experiment, it's looking at how do you improve it or answer the new questions that come, which is the same thing as the engineering.
But the benefit to changing this is to expose kids to engineering so that little kids that are not exposed to it all of a sudden understand that I can do this. Like, we have a problem right now in our culture where people think that they're not smart enough because they're not good at math and science, which who gives them that idea? But they think, I'm not good enough at this to become an engineer. But if we give them the opportunity to solve problems, then they're going to be willing to try, and they might be willing to go into that career.
So, go ahead.
And I think that there's also, well, many of us understand that the scientific method is a suggestion, it's fluid, it's creative. We have codified it so much through the years that the students don't see it that way. They don't see it as a creative process, whereas engineering still is. So.
Any other ideas?
Having come from that side and before becoming a teacher, I was a military engineer officer. we embraced it the other way. It's nothing new. You've already experienced it. It's how it's presented. I mean, that's what I'm saying.
Yeah, no, and that's good, that's true.
Yeah.
What do you think about it? Yeah.
I think that it's very similar. Like, I like what you said about it being solving a problem. Isn't that one of the things that we're aiming for?
So what is this, as she said, engineering is about solving problems. She said it's also about identifying its answer for a particular thing. Yes?
Something I caught on, I'm an engineering student dropout, senior year,
Not your fault.
make the connection.
Not your fault.
Couldn't make the connections in my senior year. It's not my fault, you're right. My brain just started understanding it about 5 years ago, which is 10 years into teaching. But something that you said that's different is you said, like, how much energy. You said that you didn't want to waste the energy. Engineers look at optimizing systems, whereas scientists don't necessarily, scientists look more at the how. The scientific process looks at the how, not the optimization, whereas engineers really look at the optimization. How do I make it so that I'm using the resources that I have?
So, yes, go ahead, sir.
I really think it's just semantics you guys are arguing, to be honest. I think the only, sorry, I'm going to say it, I'm going to piss people off. It's a STEM field, and engineering doesn't come up in the high school, and it's a way that they can use the word engineering and attack STEM.
Exactly.
Otherwise, you don't do STEM, you do science and math. And then you tell kids they're going to go with engineering, but we've never brought up the word engineering, so that they don't know what engineering is. So it's just a way of changing the semantics a little bit, getting engineering involved, so that kids can see that science and engineering and math are all.
I'm going to piggyback on one of those things. Okay. You said changing the semantics. Does changing semantics help children?
Yes.
So possibly this is in addition to it just being problem solving versus maybe it is a semantics which relates to children more than what we think we should relate to children. Yes, go ahead.
I was going to say going to piggyback off of that idea. I think it's a little deeper than semantics. Like, I think we can all agree that the processes for experimental and engineering, they're very, very similar. But what I like about this is the actual reframing of the context, because that I feel like is the most valuable. It's the same skills are being employed in many different ways, but the slight shift in context to the I'm going to solve a problem, or the to, hey, this is something that I'm like, maybe I'm thinking from a physics example. Something I do with students a lot is I don't tell them what we're exploring. I keep it really vague when we start the experiment, and I always emphasize that scientists don't know what they're trying to find. They're just trying to figure out connections here. So I think the reframing, using the semantics, using the process, I think that's the big goal.
A very interesting thing you say that.
Well, and I think that we're failing ourselves if we say it's for the kids. We've been teaching SOLs, we've been doing all of this for long enough that we need the semantic shift to reframe how we teach. It's for us as well, in changing our focus.
I ask a simple question. Yes, go ahead.
I think the concept of building is really critical here. It's something very tangible. Sometimes when we do experiments, we're not exactly building something, we're observing something, but we're not exactly building it. And if we're talking about the concept of building models and building memories and creating those impressions on students, then we really do have to change our wording.
When we use the cookbook labs, they get this feeling like, what we're showing them has been a trick.
Yeah.
We've been manipulating it so that they see what we want them to see.
Okay. So let us say this. If we are faced with this particular problem, a student, instead of saying, go and find out when something melts or when something this thing, if we ask them a problem, how are we going to remove this candle from here and place it back here? Does it make a kind of a difference for the student? So, because it's like, I say, if you say, go to the store down the street or 2 streets away, you have a pathway. You got 2 different ways or 3 different ways you can go there. Just go out and walk around. What? Find something new and come back. What? Like, you still do not know. The children may not be equipped enough to find out what are we supposed to look for, kind of thing sometimes. So this may possibly help them to put blinders and to help them, but not necessarily. But what, to her point, when you do the building and when you're doing the testing, we are actually doing scientific method. But there is much more purposeful to do the scientific method. I have now what I want to say my system works. That may be the hypothesis. That's what I have in my engineering research most of the time. This design will work. That is the hypothesis. That's all that I can have that sometimes. Okay? So what I want to do is go back to our question. What information do you want to collect before we pull the candle out? What's one thing that children must collect? Yes?
What container is the candle in? Or
Okay.
Is the candle in a container? What's the
The candle is in
that container.
Yeah, the candle is in a metal mold.
So I would assume, like, I would want to know temperature, or what materials do I have to work with? Like,
Right.
what do I have? What do I have to be able to accomplish this? And, or if I have a baseline of materials, what do I think I would need in addition to that?
I want to know what the melting point of my wax is.
Well, not all candles melt.
Right. So what type of, yeah.
Okay, so let's find out. But what happens if it all melts in one shot?
Well, you said you want to keep it in the same shape, right?
Yeah.
So we need to know some of the parameters before we do this, right?
So, but do the student know whether it'll all melt one shot or not?
It depends on their experience.
I don't understand how, you said that we can't change the shape of the candle. So if we can't change the shape of the candle, we can't melt it
You can't melt it fully.
at
Can
all.
we cut the metal away from the candle?
Very interesting. So let's do one thing. Since we have so many questions in our hand, first of all, let's understand the melting of the candle. Like when will it melt and how will it melt? Can we just check that out first before we get to find out? So this is where the question is, hey, okay, you have all these ideas, but like her idea is like, fine. Before I can get to picking one of the ideas, I need to see what does a candle do if I heat it up. I need to know.
Temperature, it doesn't melt.
Yeah.
What's the shape of what it was in? Can you change?
So let's.
Liquid form and have it.
I'm going to request you all to now move to the experimental side of this one. In another 10 minutes, I know.
Here, I've got some.
No, it's okay, I don't even need it. It's driving me crazy. There's stuff on my desk. Here. Like, and so this is something I don't even know if there are paper towels in this room. What is cute? I'm just wondering.
Do you want some sunglasses? To clean up my purse.
Here.
I know, I'm sitting here going, just remove this. No,
No,
it's
I'm
not gonna work
watching you.
anyway.
I'm watching you like, you're like, this is driving me crazy.
I know, I'm like,
Okay.
this is my engineering project.
So let's do one thing. I will give each team one of this is having is molten wax. All I'm going to give every team is a tube of molten wax and a thermometer, and I want you to see what happens to it over a period of time. Sir, or anybody else can come here, please. I have set up one more thing. This thing. Insert a thermometer into that. I would. So, what, as scientists, what would you do as it is cooling? First thing. Take data. So, what kind of data will you collect?
Initial temperature.
So, you collect the initial temperature, and then what else will you see?
Temperature and time.
Oh, temperature and time. You're all geniuses.
what I wasn't
You can take it out. Yes. Put it in the rack, and put a thermometer there inside.
Right now, I got
You were also working together? That's okay.
56. So our initial.
Okay, one of us said this process is going to take too long, but I don't have time. What do I do? Well, how do I make this process faster?
You take water and start the temperature of cooling water down and.
Okay, so what is better than water?
Ice.
Okay. Now you have more tools in your hand. Possibly you can do this.
Cold water works.
Oh!
I mean, for us, we were the first people to have them out, so.
Okay. Well, what did you see about the temperature?
How did you get this ice so quickly?
I've been making
Behind?
it since Friday.
Wait, what?
It actually looks like really old
Yes.
ice.
See, we have to go all the way to the
Break off summer.
Here. Here. Put some ice. So, I want you to measure the temperature as you go on. Did the temperature suddenly change?
But at least in the research, your clock and see how long it takes to.
So, when do you think it really melt? When do you think it will really freeze? Do you have an idea?
All right, we're starting at 53. 53 at time 0.
So, what's the temperature now?
It's 50 and I have some solid already.
Ah, interesting. Is the temperature changing much?
It went down 6 degrees. Or 8. Yeah, so at 50 we had solid.
So, what's the temperature now? Okay, but is the temperature changing much at that point of time?
There is no thing happening.
I want to tell you straight, we did that. We made them take it every 30 seconds.
Every 30 seconds, and then you do. This is already done.
Yeah, need more time. But it's almost there.
All right, we're at 60. What are we at now?
50, or sorry, 48.
Yeah, it's an observation. Yeah. Actually, that'd be really good because the difference between like it being in this controlled environment versus like is so much more.
So, what did you find out?
In terms of
Temperature and it's solidifying.
yeah, I mean the colder the surroundings are, the faster it goes.
The faster it goes, number one. Did it remain a liquid for a reasonable amount of time, and liquid and solid together at some point of time?
So, yeah, actually, I mean because there's the very bottom, it solidified.
So the temperature is not changing for quite some time?
Yeah, for a majority of it, yeah. You saw the plateau.
You saw the plateau?
You see the plateau.
So okay, you saw, most of you,
Yeah, exactly.
so you saw the plateau too?
So I have a question. I actually do not understand the goal. Like our goal is to remove the candle.
Yes.
But it removes already. So like as though it was stuck, right? Okay. So the goal is to remove the candle, but while it's lit, or while it's
Well, it's not lit. Okay, usually the molds will stick a lot. The one I bought was sitting in the car, so it just melted a little bit. So
There we go. You just stick them in your car for an hour.
hey, tells you what temperature it goes to.
Oh, yeah, the temperature reading on your hot plate.
No, don't do that.
It melted.
Okay, you're right. I get you.
How's the temperature then?
Yeah. But it doesn't hit the sides. What? It doesn't hit the sides. Okay.
But it won't. It's better in the bath.
Yeah.
It's a lot
Put the
better.
water back on.
Because it was hot enough.
Is it hot enough?
Put your finger in, man.
I'm good. You're right. Like just holding it long enough to melt the.
So it doesn't need to be lit, we just need to get the candle from one spot to the other.
Exactly.
So we just need to melt just a
So
thin
the
layer around
question,
the edges.
the question is that this creates a kind of a engineering process. I don't want to spend more energy. I need to exactly get it to 45, 50 degrees. I will put it in a bath, maybe just about that height, because he's having an issue, right? Now he's putting his hand there. I would like to put it on a tray which gives water only to the particular level.
It's so deep, yeah, I would just.
So all of these things is what you think of.
Okay, so this is why we have this. So we could have dumped a little water and set it in there, and then you didn't have to hold it.
Before I had kids,
You have to get a handle.
So-
And you'll know exactly when it's.
So there is a lot of science, and then she mentioned this thing. I keep asking the question. She said, "Why not put a hot plate? Why not put it?" But it is it's metal. It'll easily conduct everywhere. You
Which
said,
is what you wanted it to do.
yeah. So there are issues which you want to think about. All of those
It
things.
won't necessarily conduct evenly. Because
Right, well, because there's also that cushion of air underneath. I didn't realize that there were feet on the thing, which actually
So,
ran into the lab.
so these are technical issues we want to talk about. Number one. Number two, there are also question of manufacturing and other kind of issues we want to talk about all the time. How much amount of space will, if I have thousands of them going, how much space do I give between both of them? But wait a minute, if I have to maintain the same temperature all the time, what do I do? So these questions bring a lot of design issues for them. And it brings back a lot of science into it from the back door.
Oh, yeah, absolutely. The good thing is you have the group that are like, we don't have to go too crazy. Like, we were like, let's just simplify. Let's figure this out. Right? The other groups, like I'm looking around, they got wax on their paper and doing different things. I like that.
But that is something that's sharing. Like, yeah.
The kids do this. They look at the group next to them and they're
I will put it. And the next thing, only warning, don't put it on the desk. I don't want to scrape it.
they know stuff. They just forget that they know.
I'm telling you.
testing from year to year because to get it out of there is a
I spilled some wax on my desk now, table now. Before tomorrow morning, the building engineer is going to send an email saying that there is wax on your table, please clean this immediately, and he'll copy the topmost chain to the bottommost guy. I am my building engineer's nightmare. Okay, so
Get the tea light out, but I'm burning.
okay, let's.
Take this out.
So what did you observe? So
Maybe take it out, take this back to the thing.
So you could remove this? Yes. What? It didn't go. It didn't come out.
Somebody has squeezed it.
Well, they could do this. They could do this experiment, or they have to.
So no, don't rip it. You need to know. You use a nice.
I'm not ripping it. I'm just slipping those up that are slipped down. I'm being all gentle. Step back. Sorry.
See, it's not just the children. It's us too.
Oh, yeah, that's okay. Now it fell right out.
Thank you very much. Let's get back.
I couldn't remember what the objective of the experiment was, so.
Objective of the experiment was to remove the candle from the mold.
Oh. melt, then you just
So what they were trying to do was melt gently the wax only in the corner so that you can pull it out. In order to do that, you must know the whole wax will not melt in one shot.
okay.
So you're looking at the phase change concept where it takes a lot.
Nice to have the objective up on the board. That's why I was applying.
Okay, sure. I have it here. There it is.
Here's what it's showing.
T, are we gonna just turn the heat off?
Yeah. Please turn off the heaters, please. We may not have too much time. Krista,
We don't even use our hot plates.
you'll have to give me time till tomorrow to come and clean this.
Oh, yeah, that's fine.
Okay,
This
because
room's not being.
I need to run from here to give a
That's fine.
math.
I'm gonna steal my cords back because those are my cords.
Okay. No, I want to run from here to a math PD.
Okay.
I'm giving a math PD in the afternoon for 2 hours. So
That's fine, yeah. No, if you wanna, yeah, I'll be here tomorrow. Whatever. I'm just next to you.
Time-wise, yes. Color with rainbow color.
Okay, can you all have your seats for a minute, please?
Do anything fun.
Usually you do
Why
these
not?
one or
What
two
do you mean
people
you don't
that
get
translate.
Well, because it's all about cells and we get to look at cells underneath the microscope.
Yeah.
We don't
Yeah.
use any of the tests.
There's a lot of great projects. Have you ever done international or heard of
To our
the
cheek cells.
Public School Network?
Please regroup into your seats for a minute.
Yes. is that-
Not too long, we need to leave.
Do you work? Where do you work?
No, I will clean it up, don't worry. Just leave it.
It's called
Yeah.
As long as you shut off the heater,
She's
I'll take care of it.
teaching with me.
International Public
Is that a baby?
We just feel bad that we left the thermometer in the box.
Prior to 3 years old, my husband
You just put away the water,
got
everything.
connected with me. Yeah.
See,
Retiring in a year and a half. And I told her she has DVIs because she said she's
as teachers, this is also one more interesting thing, is that, yeah, we all talk about water boils at 100 degrees and then you can measure the temperature. But you know, water boiling is an annoying thing. It is a question, and ice melting, it never the temperature is a plateau because ice is all in all kind of things. Some places hot, some places cold, all kind of, and it's so hot and you don't want children there. Picking materials for them to see the same information in a much easier kind of context, like a wax. There is one more thing called hyaluronic acid, which you use for all your creams and all of those things. So that also can be used. But also around 60 degrees is this is about 55, 57 degrees. Wax slightly changes depending upon what they put inside that. It slightly changes. And yeah, so around depending upon the wax could go all the way to 60 to some of them are much easier. So, and as he said, there are some wax blends they make, bang, it just goes up in fire, like, you know. So, but that means they're adding stuff to it. It's not pure, just paraffin wax kind of thing. And you never put it on the flame because it is a kind of fuel, so you don't put it on the flame. That's never. So these are kind of things which can bring about. Thank you very much, and I hope this could help you think how you can plan your engineering design work, and possibly I will take if you can help me, write down your names on one of your papers, on one of the papers. I might possibly email you all a kind of a, what do you call it, survey. I will look at it and then tell me how it was useful, how it can be better. Can you just put your names there and then go? I can find your email.
Just have Brian send it out.
Yeah.
This one.
Just have Brian send it, and we can do it on, like,
Ask Brian for the.
Or you can all email me.
put it in the Google Classroom.
The Google Drive. We're on there.
Google Drive.
It's not Mr.T.
Okay. Sure, sure. So,
That's how I find out you were there.
I'll just give you my email.
okay. You just write your name, I'll find the email. Thank you.
You need this marker.
Samantha, we need to go.
I'm gonna write next to you.
Thank you.
I'd say this. I would definitely say this. Middle school to high school. I think you could. This is doable in middle school, but not. Like, you have to say.
Yeah.
I think you could do it. But you have a different challenge. Like.
Yeah, so I'm just like thinking about this one.
What's great about this is it's very. You could do a lot of conceptual stuff with it. You don't have to dive into the math unless you want to.
Oh my goodness, I tried to get them to do an average the other day.
So, most of these science concepts are multiple levels of diving in.
They don't know how to use calculators.
Yeah, everything's gotta be complicated.
No, that's a different one.
Anyways, I was gonna say the International Public Schools Network, they have a bunch of projects. I mean, they're a portfolio-based.
Push, I'll meet you downstairs.
I'm here.
Oh, you're
They're a
okay.
portfolio-based school system.
Okay.
That have waiver, in New York, they have waivers
Thank
from
you.
the state.
Welcome.
So instead of standardized tests.
Thank you for
portfolios.
being kind to me.
It used to be called BGLA.